طيب بسم الله الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين. حياكم الله يا شباب in the second lecture. So this lecture will be inshallah recorded for you, and you can يعني watch it before next class. So we will start with the first chapter of thermodynamics 1. So let me share my screen to the notepad. Okay. So this is chapter 1. So we'll talk about some introduction, okay? خط لكم عليه شوي because of some difficulties here, but so yeah. So as I said, ya shabab, in the first lecture, thermodynamics is the science of energy transfer. You have energy, and this energy transfer by multiple means. So it can transfer by heat, and it can also transfer by also the other type of energy we talked about is work. Okay, so the thermodynamics cares about this energy transfer by heat and work, and how this transfer affects the properties of substances. So effect on properties. Okay, so this is generally the thermodynamics. Okay, so it's very important to understand that thing. So today we'll talk about few concepts that also are important in thermodynamics. If you remember, Shabab, in the example of the hot coffee we talked about before, so let's say I have this coffee, okay, and this is now coffee, right? All right, so let's say it's hot. Okay, let's say I'm interested in understanding how the heat transfer from the coffee to the surrounding. So I want to understand how the properties of the coffee changes from state 1 to state 2, or from one point to the other point. So this coffee in this case, ya shabab, is what we call, this coffee is what we call now my system. Okay. So a system is basically whatever you are interested in to study. So I'm interested in the coffee, then this is my system. Okay. But what is the thing outside the coffee, away from the coffee? We said, let's assume that this coffee is hot at 80 degrees Celsius. Okay. And this outside the ambient temperature here is 25, let's say, degrees Celsius. So what do we call this? Outside the system, this is what we call surrounding. Okay, this is the other concept in this case. This is what we call surrounding. Okay, this is the surrounding. Like what separates the surrounding from the system is what we call, there is a line that separates the system from the surrounding. This line is what we call, or in this case dash lines, is what we call, okay, is what we call system boundary. Okay, so this is now is what we call boundary. Okay, so the boundary is what separates the system from its surrounding. Okay, so next So these are the concepts introduced now. A system is whatever we're interested in to study. The surrounding is whatever outside the system or away from the system, and the boundary is whatever separates the system from its surrounding. Okay. Uh, the other concept, ya shabab, is the type of, let's say, system. Okay, so if you notice, ya shabab, here, what do you notice? If you notice here that the mass of the coffee here is fixed. Okay, the mass of the coffee is fixed. So I have a coffee inside the cup, and this cup dimension is fixed, and the mass of the coffee is fixed, and there is energy transfer by heat. Okay, so this is what we call, ya shabab, this system, this fixed mass system, is what we call a closed system. Okay, so this is what we call a closed system, or another name for it is what we call control mass. Okay, control mass. Control mass means the mass is fixed, is controlled. Okay, it's not changing. So the mass of the system is not changing through the process or throughout the process. طيب, in this case, ya shabab, so since we have a closed system, so on the other side, so we have another type of system, which we call, okay, open system. So what is an example of open system? Okay, an example of open system is the following. So imagine I have a water pump. كلكم تعرفون الدينامو اللي في البيت مثلا. So it takes water from your from the reservoir, from the tank, and push it, let's say, on the top of the house. So this is called water pump. Okay, so it takes water from inlet. Okay, so this is water flow in. Okay, and this is, so this is here like this, and this is water flow out. Okay, so so let's say, for example, you are interested in studying how does the pressure changes from the inlet to the exit. Okay, or you are interested into studying the behavior of the water inside this pump. Okay, so in this case, ya shabab, if you notice, the dimensions of the pump is fixed, so, or the volume of this pump is fixed. So if we put a boundary around this system we are interested in, so this is our system now. I'm interested in the water inside this pump, and how does the properties change of this water inside the pump. Okay, in this case, what do you notice? You notice that the mass inside might not be fixed. Why? Because you have flow in and you have flow out. So inside here you have water. Okay, but the mass of this water is not necessarily fixed. Why? Because you have some water in, some water out. If, let's say, if the water out is more than the water in, that means the mass inside the pump is decreasing, right? And the vice versa. If the water out is less than the water going into the pump, then that means the water here is accumulating or increasing. The mass is increasing. So in this case, ya shabab, we don't call this system closed system. We call this open system. So the name for the system Since the mass now, what do you notice? The important thing you notice is that my system boundary here, I have a system boundary. Okay, so this is also system boundary. Also, I have surrounding. Okay, so I have surrounding. Let's say outside here is 25 degrees. So I still have a system surrounding. Okay, however, the water inside this boundary now, what is fixed in this case is not the mass, is the volume. So I call this an open system. Okay, so this is open system. Okay, or we call it control. ها شباب, we call it control volume. Okay, and this is the difference between the control mass and control volume. Okay, you notice that in the control volume, the boundary encloses a fixed volume. Okay, a fixed volume. However, the mass in this case crosses the system boundary here. You notice that the mass crosses the system boundary. So what is the main difference between open system and closed system? In a closed system, the mass inside the boundary in the system is fixed, and the mass does not cross the boundary. In the open system, it's the opposite. In the open system, the mass of the substance you are interested to study the mass crosses the system boundary. Okay, so in the first case in the closed system we call it control mass. In the second case, for the open system, we call it a control volume. Okay, so this is very important also to understand. Excellent. So what did we learn so far? We learned what is a system, what is a surrounding, what is a boundary. We learned that there are two different types of system. We have a closed system, we call it control mass, where the mass does not cross the system boundary, and we have an open system, we call it control volume, where the mass crosses the system boundary. Okay. طيب, similar to the system, also we have different types of boundary. Okay, if you notice, ya shabab, in these two examples, my boundary here, the dimensions or the volume or the system itself has a certain dimensions. Okay, where if we draw the system boundary, we notice that is not changing. Okay, so the system boundary is not changing. However, we could have cases or applications where the boundary itself, okay, it's a moving boundary. Okay, so in this case, in the first two examples, we have a fixed boundary. In this example now I will talk about is a moving boundary. What is a moving boundary? So let's assume I have this cylinder. Okay, let's assume I have this cylinder like this. You know what's a cylinder? Okay, and assume I have a certain liquid inside or gas or whatever. Here I have a substance inside here. Okay, and then I would like, let's say, water vapor. Let's say we have water. Okay, water vapor. So I have water vapor inside. Then I bring this, what I call a piston. Okay, I have this like a disc. Okay, I bring this piston. Okay, something like this, and this piston maybe also like this. Okay, let's actually draw it like this. All right, hopefully this is clear. So I now apply force, okay, using this on the water vapor so that the volume of the vapor changes. Okay, and the pressure changes, maybe the temperature changes. So let's assume I am interested in studying how does the properties change of this water vapor, okay, from first point to final point, or from the initial state to the final state. So if I draw my system boundary, what I will do is I will say this is the vapor that I am interested in to study. This is my system, okay, something like this. So I'm interested to study my water vapor. How does it change the behavior and how does it behave? And so this is my boundary now. Okay. And this is now my system. This is my system. And this is outside also I have surrounding. Okay. So if you notice here, let's say in initial state, this is the location of the piston. Okay. So what happened to the system boundary? Maybe I can change color here. So the new system boundary, the final system boundary, is something like this. Okay. Boundary. Okay. So what do you notice, ya shabab, here? We notice that the system boundary, or the boundary in this case, moved. So the boundary was not fixed. Okay. So this is, we call it moving, call it here moving boundary. Okay, this is a moving boundary. In the previous example, ya shabab, this is what? This is fixed boundary. This is fixed boundary. Okay, because this coffee, the dimensions of the cup is not changing, the dimensions of the water pump is not changing. In this case, this is a fixed boundary. In my case here, in this piston cylinder arrangement, I have a moving boundary. Okay, so this is the other important concept you should understand. And this piston cylinder arrangement, ya shabab, we learn it a lot, inshallah, during, we'll study it a lot. There is a lot of examples we will have using this type of system. Okay. طيب, one of you could ask one question is, so how do I select my system boundary? Because you notice now it's important to select your system boundary. So for example here, when I selected for this piston cylinder arrangement, when I try to select my system boundary, I'm interested to study what is the water vapor, right? How does it change? طيب, why didn't I choose the water vapor including, for example, the piston itself? What would this change, okay, if I included other things in my system? Okay, so maybe if I include this piston, then I need maybe to consider the weight of this piston and how does it apply on the, when I do maybe force balance, for example, if you like it used to do in the physics. So maybe diagram, maybe I'll include the weight of the piston. Okay, maybe if I don't include it in my system, then I don't have to do that. So what does it decide? So what does it decide the selection of the system boundary? This is what you might be wondering. Okay. So to answer this question, so the question is, how do I select my boundary? Okay, I'm going to select my boundary. So to answer this question, ya shabab, we need to pay attention to few things. The first thing, ya shabab, is what do you know about the system, okay, and what information are given for your system. So you should ask what is known let's ask what is or what do you know about معلش الخط مضروب شوي about your system, especially where يا شباب especially at the boundary you are selecting, at the boundary you are selecting. To clarify this يا شباب, so let's go back to this example of piston cylinder. انا قلت لكم قبل شوي انه ليش ما ادخل البستن. تخيل انا عندي السيستم وعندي information given, okay, but I don't have any information about the weight of the piston, the dimensions maybe, whatever, or the area. I don't know this information. So is it reasonable to include or not include the piston in this case? So the reasonable answer is not, I should not include it in my system. So I select my boundary where the piston is outside my system. Okay, so this is important. So you need to look into what do you know about the system, especially, okay, at the boundary you are selecting. Sometimes, or the best way to go about this is to select your system boundary where you have the most information given, okay, at the boundary and at the system. You select your boundary where you have the most information given at your system boundary. Okay, so this is very important. So this is the first point. The second point, you need to tell yourself what is the objective of the study. Okay, what is the objective, okay, of your analysis? Okay, so you want to do certain analysis. So let's say my objective is to study how does the weight of the piston affects my water vapor. This is my objective. So يعني الجواب المنطقي في الحالة هذه أو الاختيار المنطقي, the reasonable selection is I will include both the piston and the water vapor because my objective is to study the effect of the piston weight on the volume of the water vapor. For example, just this is just an example. However, someone else says, no, I want to see how does the atmospheric pressure maybe affecting with negligible piston weight, how does the atmospheric pressure affect the volume of the water vapor? In this case, maybe I don't need to include the piston. Okay, so it depends on your objective. It depends on your objective. So in order, again, as a summary, in order to select your boundary, the best way is to select your boundary where you have the most information given, okay? Especially look at the boundary you are selecting. What information are given at that boundary. The second point is you need to select your system boundary so that it can serve better or best your objective of the analysis, okay? So these are the two important points you should consider when selecting your system boundary. Okay, great. Let's say here. Let's introduce يا شباب. Just a second. Okay. Yeah, let's look into let's look into a few more concepts, and we will inshallah conclude this lecture. And I'm not gonna take long from you. So let's study what is a property. Let's define it in a better way. What is a property? What is a state? And what is a process? Okay. So here, let's look into property. So we want to define what is a property. Okay. Also, we want to define what is a state. I slightly mentioned state while discussing, and also I want to define what is a process. Okay. So let's talk about this. So a property, what is a property? Okay. A property in a simple term is a characteristic of a system. Okay. And I will give it a name, a macroscopic characteristic, a macroscopic characteristic. Okay, a macroscopic characteristic of a system. And macroscopic in this case means يا شباب it's overall يعني a general or average characteristic of a system. Okay, examples زي ايش يا شباب؟ مثل ايش؟ E dot G dot, this means for example. Okay, EG in this case means for example. So what is a macroscopic characteristic of a system? We have mass, for example. Okay, mass is a characteristic of a system. It describes the weight of the system. Another example is maybe temperature. Okay, temperature is another macroscopic characteristic. So let's say when you say the weather today, the climate is 20 degrees Celsius, the ambient is 20 degrees, you are describing the average temperature of the atmosphere. Okay, also volume also is another property, and so on. Okay, and so on. What do you notice, ya shabab, for these here properties? Does it depend on the process? Yani, if you have a system, it's going through a process. Let's say in previous example, I have water vapor. I'm trying to compress this water vapor. So if I don't compress it or I compress it, it doesn't matter. The water vapor will still have these properties. Yani before I compress, the water vapor has a mass, volume, temperature, pressure, etc. When it goes through a process, when I compress it, and still during compression, still you have mass, volume. It might be different from the first or the initial one, but in general, these characteristics always describe the system. Okay, this is the point here. These characteristics always describe the system independent of the process. So this is independent. So it does not depend independent, okay, of the process. So it does not matter what type of process the system goes through. These characteristics or these properties always describe that system at each moment in time. Okay, but I hope this is clear. The second concept I want to describe here is a state. So based on the previous discussion, what is a state? Okay, what is a state? When I tell you initial state, final state, state 1, state 2, state 3, maybe a system going through multiple states. So basically a state is condition okay, condition of a system with properties at a given time. Okay, so it gives you the state, gives you the condition of the system, condition of a system, okay, with properties at a given time. Sorry about the writing. So basically we talked about what is a property. قلنا انه characteristics macroscopic characteristic of a system like mass, temperature, volume, etc. So when the system is at a certain state, when I say initially the system is at T1 temperature 1 to P1 pressure 1, V1 volume 1, for example, this is a state. Okay, so this is the initial state that the system was described by its properties. Then it goes through a process, then it reaches a new state. Now the new state has different properties than the previous state. So basically the state gives you the condition of the system with the properties at that time, or at that moment. Okay, I hope this is also clear. Then based on this, Shabab, what is a process? If we can describe it in a simple term, process is basically transformation from one state to another. Okay, so the process is transformation from one state to another. Okay, so this is basically what is a process. طيب, what type of process? يعني maybe also a quick thing. What type of process do we have? So mainly we have two types of processes, يا شباب. We have what we call steady state process, steady state process. Okay, and the other type is what we call unsteady or transient unsteady state. Okay, unsteady state process. Let's call this SS, and let's call this US. Okay, طيب, from the name يا شباب, steady means changing or means fixed or means constant. So if we have this process, it's like a constant properties with time. So the properties of the system, so you have constant means unchanged or not changing properties with, okay. So during the process itself, the properties are not changing. How about the unsteady? The unsteady is clear now, means a changing properties with time. So unsteady is the opposite. So during the process, changing properties with time. So same as before. Okay, an example for this, Shabab, I talked about it slightly maybe before, here in the water pump. Okay, if you remember, what did I say about the water pump? This is an open system. I'm interested to study the water inside the pump. I said that if the mass flow out is more than the mass flow in, I have mass reducing in control volume itself. This is, ya shabab, unsteady state. This is, in this case, unsteady state process. However, if the mass in equals the mass out, okay, so if the mass in equals the mass out, you will notice that the mass within the control volume, this is still open system, this is still mass crossing the system boundary. However, the mass inside is not changing, is a constant mass. It doesn't mean the system is closed. No, it means the mass in equals mass out makes this mass inside almost not changing, almost. Okay? In this case, ya shabab, I call this a steady state process. Steady state flow or a steady state process. Okay? I hope the difference is clear now between a steady state process and unsteady state process. Okay? Let's see if there is anything more we talk about here. Okay. All right. I think that's all what I wanted to discuss with you today, inshallah. And inshallah, next class we'll talk about the different types of properties, and this is important. You have different types of properties. We need to focus on that more. And then we'll talk about unit and the importance of units, ya shabab, in this course, and the importance of unit conversion. Because a lot of students, and I'm telling you from now, a lot of students, mostly they make mistake in the units. Okay, because sometimes you need to change the pressure units, to change the energy units, etc. And so it's important to understand how to do this unit conversion. Okay, then we'll talk about some of the main properties that are relevant for us in this course, and I talked about some of them before, which is the volume and pressure and temperature. We'll talk about each of them slightly in some brief detail, and we'll conclude this chapter, inshallah. So hopefully this is a simple and light lecture for you, and take care, and I'll see you inshallah next class.